Hi guys, this is the second part of section 2 of chapter 9, and we are going to use what we learned yesterday, but we are going to apply in complex fraction. So you're going to only see complex fraction examples, and your homework problems are also dealing with complex fractions. So let's go to the examples. So your textbook, page 564, explains two examples. And one says complex fraction with different LCD, and the other one says with the same LCD. So I'll show you what they mean by that. Okay. So this one, so you can see that there is rational expression on the numerator and then rational expression in the denominator. So what it means by different LCD is that you're actually going to look at them separately and then deal with it, and then you're going to deal with the complex fraction once it's in one fraction. So let me do that too. So 1 in x has LCD of x, so if we make a common denominator, it would be x. So x here, and then y here. The reason I have x now is because 1 is same thing as 1 over 1. So to make 1 to be like x, you need to multiply by x. Sorry, there's an equal sign in between. And then the bottom is they have to have xy as a common denominator, right? Because LCD is x and y. So then for y, I need to multiply x because it's missing x, and for x, I need to multiply by y. So now it's just a regular complex fraction, and you know how to deal with this. I'm going to actually write it out so that you can remember how to deal with this, but then after that, I'm going to use shortcuts. So a complex fraction just means that you're dividing two fractions together. And then we know how to deal with the division because it can be written as a multiplication and, sorry, this is multiplication, reciprocal. So then when you multiply across. But before we multiply, let's cancel out something that we can. So x and x can cancel out, right? So then my final answer is y times x minus y over x plus y. If you like to distribute, you don't have to, but if you like to distribute, you can distribute like this. Okay, so that's the method 1 that the textbook is explaining. Method 2, when they say complex fraction with the same LCD, is instead of looking at the fraction differently, you're just going to look at the denominator, and then you're going to find the LCD for each denominator. So how it's looking at is this. So this is 1 over 1, right? So you have 1x and y and x as a denominator. So then LCD of all of them will be xy, correct? So then what it does is that it multiplies xy on top and xy on the bottom. So then you're not really changing any value because xy over xy will be 1. So, but then it has an kind of like simplifying effect to your complex fraction. So let's see what it looks like. One thing you need to remember is that you have to distribute, right? So this xy gets multiplied to 1, and this fraction, and this, and that fraction. So the first one would be just xy, because xy times 1 is xy. And then the second one, x cancels with this x. You see that? And then it just becomes y squared. Okay. And then the bottom, this y cancels with this y. So it's going to be just x for the first one. But then, you know, we are distributing, so you need to kind of think of it again. So there's new xy. So now this x cancels with this x. So then the only thing that's left is y. So do you see how that the answers end up being the same? So it really is up to you to choose which method you like. Obviously, method 2 is a lot simpler than method 1. And so if you like using just method 2, like I wouldn't stop you from doing that. But you just have to think more in the beginning, okay? So let me try one more time with method 1 for this example, okay? So I'm going to treat the fractions, the numerator and the denominator separately. So let's look at this. So the common denominator of D and C would be CD. So then this one is missing C, so it will become C squared. And then this one is missing D, so it will become D squared. Okay, that's the top. The bottom, it's going to be C, right? Because this is 2 over 1. So then the first part doesn't like anything because it already has a denominator of C. But then the second one has to be multiplied by C. All right, I told you I'm going to use a shortcut. So the shortcut was the inside, you multiply them together. And that becomes a denominator. CD times D plus 2C. Okay? And then the outside, you multiply them together and they become the numerator. C times C squared minus D squared. So then I can simplify the C's together, and my answer ends up being C squared minus D squared on top. And if you want, I can distribute the D's to be D squared plus 2CD. And that's the answer. Okay. Let's try method 2 for this example. So method 2, remember, I need to find I guess like you're trying to find LCD for all the denominator. So again, this one is 1, x, and y, and x. So very similar to the last example we saw. We're going to multiply xy over xy. So then you have to distribute. That is something that you shouldn't forget. So xy times 1 is xy. 2 over x times xy is 2y, okay, because x's cancel each other. And then denominator would be 3 times y gets canceled, so x minus x gets canceled, 4y. And that's the answer. Okay? All right. Next example. So, I will go with the method 2 because method 2 seems simpler to me. So again, I just need to remember that 6 is 6 over 1. So then the common denominator for all these fractions would be C times D, right? So I'm going to multiply CD on top and CD on the bottom. So then 1 over D times CD. Let me just write it out everything. So write out everything so you can see what's really going on. So basically what's going on is CD over D minus D times CD over C over CD over C plus 6CD. That's what's going on, okay? So then after that, it's just simplifying what you see like this. So that's why my answer ends up being C minus D squared on top and D plus 6CD. Okay? And even if you didn't do the green and yellow step that I did, if you can do everything in your head, then you can go straight to the red answer. So it just depends on how good your mental math is to use those. All right, I think I have more complicated examples here. Yeah. All right, so these look fun, yeah? Let's look at the first example. So these are all complex fractions, so there's nothing new to the concepts itself. It's just that there are a lot more to consider. So let's use a method 1 just because there are more going on here. One thing, this question might be impossible to do it if you don't remember that x squared minus 9 can be factored out, okay? X squared minus 9 can be factored into x minus 3 times x plus 3, okay? So this is something that you always have to remember of the factoring technique. So again, I'm using method 1. So I'm going to combine the two fractions on numerator as 1 and then the two fractions in the denominator as 1. Okay, so the LCD for both of them is x minus 3, x plus 3. And then this one, x plus 3 is missing, so it's a 2 times x plus 3 plus, and then this one doesn't like anything because it was already x minus 3 and x plus 3. Over, and if you look at the bottom, even though this is x plus 3, they will become the same common denominator as the top. And then this one is missing, x minus 3, and then this one doesn't miss. Okay, do you remember the cancellation rule in a complex fraction? Because you're multiplying the inside together, that meant that you can simplify what's alternating, okay? So these x minus 3 times x plus 3 cancels out with x minus 3 and x plus 3 because they're both in the denominator. So then, if we just use a shortcut, you multiply with the inside, and now the inside is 1 on the top. So it's just, I'm going to also distribute to save time. 3x x minus 9 minus 4x as a denominator. And then on top, it's 2x plus 6 plus 3x squared. So let me reorganize a little bit. 3x squared plus 2x plus 6 over negative x minus 9. And this is the simplest you can go because on the top, 3x squared plus 2x plus 6, there is nothing you can really factor to cancel out with the denominator. And so that's it. Last example of today, which is the same thing, but this time we're actually going to use the method 2. Okay, so do you see how there's x plus 6, 2x minus 1 as a denominator? So that means that I'm going to multiply x plus 6 times 2x minus 1 on top and x plus 6 times 2x minus 1 on the bottom. So I'm essentially multiplying by 1, so nothing is changing. Again, we need to think of it as a distribution. This is going to be a little bit longer. So the first part, the x plus 6 cancels with x plus 6, so it becomes 5 times 2x minus 1 minus 2x times 2x minus 1 cancels with 2x minus 1, so x plus 6 is on top. Let's go to the bottom. X times x plus 6, because 2x minus 1 will cancel with each other, and then the second one would be 2x minus 1. Okay, almost done. We just need to distribute and simplify. So 10x minus 5 minus 2x squared minus 12x over x squared plus 6x plus 8x minus 4. All right, let's write it as a standard form. And the bottom would be x squared plus 14x minus 4. And that's it. You can't factor anything. You can't do anything else other than this. You are just going to leave your answers as that. And you might be asking, how do you know if something is factorable and something isn't factorable? Well, the only way I can tell you is that with practice, you will train your eyes to see if something is easily factorable or not so easily factorable. Alright, so again, homework is these just 4 questions. And again, if the lesson was too confusing and if you watched a third time and you still don't get it, please don't hesitate to email me, comment, whatever, to get my attention so that I can help you better. Okay, I will see you tomorrow. Bye.